Hello everyone, I'm Landon Schlungen. I'm back and we're going to learn recursion by building a decimal to binary converter. They added 3 extra to the local storage by building a to-do app, but I'm gonna skip that. And we're going to just start with the recursion binary converter. There's a lot of challenges in this one, 108, so we better get started. Uh, this is what we're going to be building. If we enter a decimal number, say like 6, then it returns 110. And that's binary for 6. I think it's because it's like 2 squared plus 1 squared or something. Yeah, something like that. I don't know. I forgot. Okay, let's do this. Step 1. Think, did I do this already? Yeah, I did. Step 1 I already did, but you just have to add the get element by ID for number input, convert button, and the result. And then we should be good to go. Step 2, now we'll have to do some setup to check the value in the number input element whenever the user clicks the convert button. First, create an empty function called check user input. Create function check user input. There we go. A good way to test that everything is working is to log the value attribute of number input to the console. As a reminder, you can access the value attribute. Okay. Within the check user input, use console.log console.log to log the value of number input. All right, should be fine. Nope. To log the value. Okay, number input dot value. That's what I have to do. There we go. So if I put in like 7 here and check the console, I guess I'm not running this function yet. I need to bind that button to this function. Now that your check user input function is set up for testing, you can use an event listener to call a function. Yep. Okay, so chain the .add event listener to the convert button. So convert button dot event listener. The event listener should listen for a click. Okay, so you just need to put click here and then a arrow function that, well, actually it should just call the check user input, right? So I don't need an arrow function here. Just put check user input is the function, and that should be fine. So if I put in like 5 here and check the console, then we get 5 in the console. Okay. Now it's working. Yep. The key down event fires every time a user presses a key. Chain add event listener to number input. Okay. Number input add event listener. We need to put the key down for every time they press a key, and then for the function, it should be an empty arrow function. Okay. So we do an empty arrow function like so, and that should be fine for this one. Whenever an event listener is triggered by an event object is created automatically. You don't always need to use this object. Okay, first pass E as a parameter to your callback function. There's the event parameter. Next, log E to the console. Okay. Console.log E. And then if I check my console every time I do this, we just have is trusted getter. Okay, that's not very helpful. Yeah, we see that object type to the console. When we want to, the most helpful property is key, so I think we can do e.key. Let's see here, e.key, and then check the console. Put in a number, ASDF, that's what I put, 234, yep, perfect. So remove the console log and add an if statement to check if it's a string of enter. Okay, so if e.key equals enter, then we want to do something. Since the enter and return keys have similar functions, they both have a string of enter. Okay, just delete the console. Okay, should be fine. Yep. Next, within the body of the if statement, call the check user input function. After this, if you enter numbers into the number input and press the enter return key, you should see numbers logged to the console. Huh. Yep. Okay. Perfect. Now that your convert button and number input are listening for clicks and enter key presses, it's time to complete the check user input function. So we should be in that. Yep. It would be helpful to alert users if they don't enter a value into the number input or the number they enter is invalid. So we need to check if the input type is number. Use an if statement to check if the value is an empty string. If number input dot value equals an empty string, leave the body of the if statement empty for now. Okay. In an earlier project, we learned about truthy and falsy values. Yeah. So some falsy values are null, undefined, and zero. We can do a not with an exclamation point under the condition in your if statement. To use the logical not operator to check if number input dot value is falsy. Oh, okay, so if not number input dot value. I see. That's what they want right there. If not number input dot value. Because the input type number element allows special characters like period plus e, users can input floats like 2.2. Yeah, a good way to check and normalize numbers is to use the built-in parse int. Okay, parse int will make sure it's an integer, add a logical or operator, or then pass a number input into the parse int function. Parse int number inputs dot value. Pretty sure I have to do dot value. Yep, okay, perfect. Next, we need to check if the value returned by the parse int function is a number or not. We can do that with the isNaN function. This function takes in a string or number as an argument and returns true if it evaluates to an AN. IsNaN, so test is not a number, so it returns true. Take the second condition to use the isNaN function to check if the value returned by parse int is nan. Okay, so we just have to wrap this within isNaN. Wrap this part. Okay, and then that will turn true or false. Okay, let's see if that's right. Nope, it's not. Wrap the value returned by parse int in the isNaN. Oh, okay, I just spelled it wrong. It's a lowercase I. Now, is less than 0. Okay, check if it's less than 0. Less than 0. How does it work? No. Which checks the value returned by parse int to be less than 0. Add a third condition. Oh, add a third condition. Add a third condition. Or to check the value returned by parse int. We should wrap the value returned by parse int in the isNaN function and add a third condition which checks the value returned by parse int to be less than 0. Oh my god, okay, so we just need another one of these is less than 0. Like that. There we go. Yeah. So kind of long one. Long if statement there, or long conditional. Now you can alert the user if they don't enter a number. Okay, so in the body of the if statement, use the alert method. Alert method to display the text of this. Let's just copy and paste that. Note that alert method on the window object in the browser. Yep, okay, so if I put in a E, then it says please provide a decimal number greater than 0. After alerting the user if the number input is empty or the value is not a number, you can use the return keyword to break out of the function. Return. There we go. Now you'll start building the function to actually do the decimal to binary conversion. Create a function called decimal to binary. Okay, function decimal to binary with input as a parameter. Leave the body empty for now. Within your check user input function, remove the console.log. I can do that. Then call the decimal to binary function and pass in the value of number input.value as an argument. Also make sure to use the parseInt function to convert it into a number. Okay, parse int, and then wrap that, and that should be good. Yep. Finally, you should clear the number input by setting its value to an empty string. Okay, so number input dot value equals an empty string. Now that your function is set up, it's time to learn about binary numbers. Binary numbers are a base 2 number system, unlike base 10 or decimal number systems we use every day. Okay, so in computer science, these binary digits are called bits and are the smallest unit of data computers can process. For computers, 0 represents false or off, and 1 represents true or on. In your decimal to binary function, use a return keyword to return a string of binary numbers representation of true. Okay, so return a string of binary. Okay, so 1, return 1. Is that right? Yeah, okay, perfect. In the base 2 number system, the rightmost digit represents the 1's place, the next digit to the left represents the 2's place, then the 4's place, then the 8's place. Okay. Here are numbers 0 to 9 in the base 10 and base 2 number systems. So last time I did 6 because it's like, what is it? It's like 4 plus 2. That's what it is. 4 plus 2. This one would be just 1. Then it would be 2 plus 0, which is 2. Then it's like 2 plus 1. Then it's 4 plus 0 plus 0. Then it's 4 plus 0 plus 1. I think that's how it works. Okay. Notice that binary numbers are formed from left to right, from the digit with the greatest value on the left to the least significant on the right. So that's the same as what we have with the base 10 system. In your decimal to binary function, convert the number 10 into binary. Okay, convert the number 10 into binary. What is 10? That would be like 8 plus 2, so it would be like that. 8 plus 2. I think that's right. Yep, there we go. Perfect. Bits are often grouped into an octet, which is an 8-bit set known as a byte. A byte can represent any number between 0 and 255. Here are the placement values for each bit in a byte. So yeah, the first one would be the largest number, 128. And by adding up these numbers, we can get any number between 0 and 255. Okay. In your decimal to binary function, convert the number 118 into binary with leading zeros and return it as a string. With leading zeros, okay. So it's lower than 128, so that's a 0. We need a 64 in there. 64 plus 32 would be 90 something. 96, so we need that. Plus 16 would be 112, so we do need that one. And then we need 6 more on top of that, which would be 0, 1, 1, 0. I think it's like that. Let's go. I'm a genius. Oh my god. And now that you're familiar with binary numbers, it's time to finish building the function to do the conversion for you. You'll start off with a simpler solution first, then refactor that into a recursive solution. First, we need to create some arrays to store the inputs and results of the division you'll do in the following steps. Remove the return statement. Then declare the variables named inputs, quotients, and remainders. Okay. Declare variables. Okay, so let or const. Let's use let inputs. Let inputs. Let quotients. Let remainders. And assign them to an empty array for each of them. Oh, okay, perfect. Whoops. Let's go like this actually and grab all of them at once. And then equals an empty array. See if that works. Yep. Set input. Oh, they did want const, whatever. Set input equal to the number 0 for now. Input equal to 0. Does that have to be a let? No, okay, we're good. Oh, input is the parameter. Okay. For the decimal to binary conversion, you need to divide input by 2 until the quotient or the result of dividing two numbers is 0. But since you don't know how many times you need to divide by 2, you can use a while loop. Yeah, so while loop is good if you don't know how many loops you're going to run. Whereas for loops are better for if you do know how many loops you need to run. Um, okay, so what do we have to do here? Create a while loop that runs as long as input is greater than 0. While input is greater than 0, and leave the body empty. Okay. Tricky part about while loops is that if you're not careful, they can run forever. Yep, so that would be an infinite loop and it causes the browser to crash. To avoid infinite loops, we need to make sure the condition eventually becomes false. Make sure the input variable eventually becomes 0. To do that, we can do like input minus minus, I think. Move the input equals 0 statement into the body of the while loop. This will make sure it will only run one time. Input equals 0. Wait, move it into there. Oops. There we go. Should be good. To divide numbers in JavaScript, use the divisor operator, which is a slash. In the example above, yep, okay, inside your while loop, create a variable named quotient, like quotient, and assign it the value of input divided by 2. There we go. Next, we need to use the math.floor function to round down to the quotient of input. So we can do math.floor around this. Math.floor around input divided by 2 to make it a whole number. Now that you have an operator that will lower the value of input each time the loop runs, we don't have to worry about this thing. So I can delete this, right? Update the last line of your while loop and assign quotient to input. Oh, whoops. Input equals quotient. Okay, that should be good. Next, you need to calculate the remainder of input divided by 2. You can do this with the remainder operator, which is the modulus, the percent sign. It returns the remainder of the division of two numbers. So 5 modulus 2 is 1 because 5 divided by 2 has a remainder of 1. Okay, inside your while loop, create a variable named remainder. Let remainder equal, and use the remainder operator to assign it the remainder of input modulus 2. Input modulus 2. There we go. Inside your while loop, use the push method to append input to the inputs array. So inputs.push input. There we go. Use the push to append the quotient variable to the quotients array. Quotients dot quotient. Whoops. Quotient dot push quotient. Yeah. Also append remainder. So we need remainders as well. Remainders dot push remainder. There we go. Perfect. Now is a good time to check our work. Log the text inputs followed by a comma followed by inputs array to the console. Okay, console.log inputs and then plus inputs. There we go. Let's see here, console. And if we put in like 4 convert, we get 421. If we do like 145, we get this. And I guess we're going to use that in the next sections. What do I need? I just, instead of a plus, I need a comma. Okay, whatever, it's fine. Same thing. Next, log the text quotients followed by comma. Okay, so we have to do the same thing, but for quotients. Let me just copy this down, Alt Shift down, Control D, quotients, and then this should be a Q of uppercase. And then same thing with the remainders. Remainders are, there we go, check that. What do I have to do? Quotients is spelled wrong. Whoops. There we go. Now, if you enter the number 6 and click the convert button, you'll see the following output: inputs of 631, quotients 310, and remainder 011. Notice that the remainders array is a binary representation of the number 6, but in reverse order. Oh, okay, cool. So we just have to flip that around and we're good, right? Use a reverse method to reverse the order of the remainders array and join with the empty string. Okay. So we need to go remainders dot reverse dot join, like so. Then set the result to inner text equal to the remainders, right? Remainders. Is that right? No way. Yeah, because this has to be set to something. You should use the join method with an empty string. Oh, that's what I had wrong. You should set the result to inner text equal to the binary number string. Oh, I just need to put this here. That's why. Control X, Control paste. There we go. Your decimal to the binary function works well, but there's an issue because of the condition of our while loop. It only works for numbers greater than 0. If we try and convert 0 to binary, nothing will get added to the page. To fix this, we need an if statement to check if it's equal to 0. If input is equal to 0, then we're just going to return 0. I'm suspecting, basically. Then use an early return statement. Return to break out of the function equal to the string 0. Oops. There we go. No. Should set the set the inner text to that. Whoops. My bad. Yeah, okay. So result dot inner text equals 0 as a string. Now our decimal to binary function is complete. Feel free to play around with it. What the heck is the rest of the challenges for? Aren't we done? But apparently we have to do stuff with the call stack. I didn't even really notice that before. Okay, so there's ways to improve this thing. First, remove everything in the body of the decimal to binary function. And then use let to create a variable named binary and assign it to an empty string. Okay, remove everything in the body of the decimal to binary function. Okay, so that's everything of this. Okay, oops. God dang it. Solve this here. Oh my god. This is annoying. Delete. Then use let equal to let binary and assign it to an empty string. Okay. Cool. Since you'll want to display the result of the conversion, assign the binary variable to the inner text property. Result inner text. Okay. Result inner text equals binary. Create a while loop that runs as long as input is greater than 0. While input is greater than 0. Inside loop assign 0 to input for now. Input equals 0. Be careful not to trigger before you set it to 0, otherwise it will create an infinite loop. Recall that each time the loop runs, input is the quotient of the previous value of input divided by 2, rounded down. Eventually input is less than 1 and the loop stops running. You can do this in a single step. Inside your while loop, set input equal to the quotient of input divided by 2. Input equal to the quotient of input divided by 2. Also remember to use math.floor. Round the quotient down. Math.floor. Okay, there we go. In the previous version of this function, you pushed the remainder of input divided to the binary array, then later you reversed it, but it would be easier to use string concatenation within the loop to build the binary string from right to left. Yeah, perfect, okay. Yeah, we can do that. First, use the remainder operator on the binary equal to input. Okay, so input, use the remainder operator to set binary equal to the remainder of input modulus 2. Okay. Input modulus 2. There we go. First do that. And then when we push it onto our array, oh wait, use the addition operator to add the current value to the binary. So like that, plus equals. This is what will build the binary string from right to left. Wait, no. To add binary to the end of the equation. Should use the addition operator. Plus binary, like that. Oh, there we go. Okay. To clean things up a bit, wrap input modulus 2 in parentheses, so we know what's getting done first, I guess. It just makes order of operations easier to understand. Finally, you need to handle cases where input is 0. Rather than update the DOM, you can update the binary string and let the rest of the code in the function run. Create an if statement that checks if input is equal to 0. If it is, set binary equal to the string 0. Yeah, okay. Awesome. Now we have a more efficient way to convert decimal numbers into binary. After learning a bit about the call stack and recursion, you'll refactor the decimal to binary function to use recursion instead of while loop. Create a function named A. Function A that returns the following: FreeCodeCamp return FreeCodeCamp plus B, which is another function. I guess we're gonna learn recursion now. Next, create a function named B. Function B that returns the following: is plus C, and also create a function named C that returns awesome. So function C returns, whoops, I forgot the return keyword in the other one. Return awesome. So I just need to put return here. There we go. Finally, call A from within a console.log, console.log A, and log the statement to the console. In computer science, a stack is a data structure. Okay, so now we're going to learn about this call stack then, where items are stored in a last in, first out manner. If you imagine a stack of books, the last book you add to the stack is the first book you can take off the stack. Or another way is like thinking of plates at your dining hall out, or like at a buffet, you pull it off the stack, but like when they were first put on there, you put the last one at the bottom is the last one that gets taken off. Or like even, yeah, stack of books. Yeah, so stack makes sense. Or an array where you can only push or pop elements. The call stack is a collection of function calls stored in stack structure. When you call a function, it is added to the top of the stack, and when it returns, it is removed from the top or end of the stack. You'll see this in action by creating a mock call stack. Initialize a variable named call stack. Okay, so let's call stack and assign it to an empty array. Okay, when your code runs, the A function is added to the call stack first. In your call stack array, add the following string A. Okay, A returns. Okay, so I do actually have to use the single quotes. Darn it. Single quote, and then I have to put double quotes in here. Free code camp. Oh my god. Free code camp plus B. This represents the function call and the code that will be executed. Since the string you're added includes double quote. Yeah, okay. What do I do? Returns. There we go. Then since A calls B, the function B is added to call stack. Next add this. Okay, I should probably just copy this. I don't know why I typed it all out last time. That was kind of dumb. Let's check that. And then the last one is C returns. Let's just add that quick. Paste that. Okay, your call stack is complete. As you can see, A is at the bottom of the beginning of the stack, while B is in the middle, and C is at the top or end. Once they're all in place, then they begin to execute from top to bottom. Okay, C executes, returns the string awesome, and is popped off or removed from the top of the stack. Remove the C string from the top of the call stack. Okay, so this is the top, so I guess. So that gets popped off the top and returned first. Then this gets returned. Um, Update your mock call so it looks like B. Oh, and then C becomes awesome. Yeah. Oh God, I'm just gonna copy this because all the quotes are messed up. Okay, so the C function becomes awesome, and then this B function will become return is awesome or something. Is awesome. Yeah. So let me copy this and take off B, and we'll just have A. There we go. Finally, A returns a concatenated string of FreeCodeCamp is awesome. Pop A off the top of the call stack. Wow. We really accomplished a lot with that one. Holy. There's like 12 challenges and we did nothing. But we learned a lot. That's what matters. While that's a simple example, it demonstrates how the call stack steps through your code and calls multiple functions. Now it's time to jump into recursion and see how the call stack fits into this picture. So we need to remove our call stack array. Okay. The A, B, and C function and console log. Okay, so delete all of this. Now you'll create a function that will count down from a given number to 0 using recursion. Create a new function named countdown. Function count down with a number as a parameter. Number. And leave the body empty. First thing you need to do is log the current value of number. So console.log number. Okay, move on. The recursive function is a function that calls itself over and over, but you have to be careful because you can easily create an infinite loop. That's where a base case comes in. So that would be like the condition of when it should stop. It's when the function stops calling itself. It's a good idea to write it first so we don't have any infinite loops. So since our countdown function will count down from a given number to 0, base case is when the number is equal to 0. Okay, so we have to use an if statement. If number is equal to 0, then we return out of the function. Okay. Recursive functions also have a recursive case, which is where the function calls itself. First, convert your if statement. Yeah, so this is what makes a recursive function is that it calls itself. So first, convert your if statement into an if else. Leave the body of your else statement empty for now, but we are going to call it, I'm guessing, we're going to call countdown in our else. Okay. You need to remember two things. What is the base case? What is the least amount of work we need to get closer to the base case? So since our base case is when number is equals to 0, you need to call countdown again while also lowering the value of number by 1. So we need to call countdown, count down, and then pass in number minus 1, like so. So it's going to call it again, but the number is going to be 1 less than it was before. It's time to test our function, call countdown with an argument of 3. Count down with an argument of 3, and then we should see in the console 3, 2, 1, 0. There we go. Perfect. To really see the call stack in action, you just need to modify the function slightly. First, rename the countdown function to countdown and up. Okay, countdown and up. Remember to update your function calls too. So this too. Okay. In your base case, log reached base case to the console. Console.log reached base case. Number 64, then log the number to the console after your recursive countdown. Okay. So console.log number. Okay. Now you should see a countdown from 2 to 0, followed by reach base case and a count from 1 to 3. Let's see here. Console 3, 2, 1, then 1, 2, 3. This is because after the recursive loop is finished, the function will continue to execute the code after the recursive call. This is why you see reach base case before the count from 1 to 3. Let's see here. Reached base case, then going back up to 1 to 3. Interesting. Now that you have a better understanding of how the call stack and recursion works, you'll refactor the decimal to binary function to use recursion instead of while loop. Wait, how does this work here? After the recursive loop is finished, the function will continue to execute the code after the recursive call. This is why you see reach base case before the count from 1 to 3. Okay, so we reach the base case, and then we continue to console log more numbers. Huh. Interesting. Yeah, that's why recursion isn't very recommended. It's like very inefficient because it calls it like way more than it has to. Okay, let's check the code. Oh yeah, I have to delete all this, right? Now let's go on. Then remove the contents of your decimal to binary function. Okay. As a reminder, it's often best to start with the base case. Okay, so use an if statement. Input is equal to 0. And if it is, return an empty string. Okay. For the recursive case, add an else statement, or else block, I should say, and return the result of calling decimal to binary. Pass in input divided by 2, rounded with mat.floor. Mat.floor. Okay, that should be good. This effectively lowers the input by roughly half. Yeah, we know that. We've done this like 5 times. After you call, use the addition operator to concatenate the remainder of input divided by 2. After you call this, use the addition operator. Wait, we have to do like a plus here, right? Plus input divided by 2 to the end of string. Also wrap the operation in parentheses. Wrap this in parentheses. Is this right? I don't think so. You should use the addition to concatenate the remainder. Oh, remainder, not division. I need to use modulus. How does that work? Yeah, perfect. Finally, in your check user input function, okay, that's where I am right now. Yeah, check user input. Set the text content property of result. Set the text content property of result. Set the text content property equal to the string returned. Okay. So result dot text content equals decimal to binary function. Okay, there we go. Converter should be working now. So if I put in 7, convert 111, perfect. But if you test your converter with 0, you'll see nothing happens. So if I do 0, nothing happens. It doesn't do 0. Update your base case so that it returns 0. There we go. This mostly works if you convert 0 into it's displayed on the page. If you convert 1, the result is 0, 1. But if you think about it, 0, 1 is in base 10, always converts to 0, and 1 in base 2. So you can add another base case to handle when input is 1. Because when it's 1, it should just be 1. And else if input equals 1, then return 1. Return 1. Okay, perfect. Now everything should work as expected. For a reliable way to convert a value into string, even false values like null, you can use a string function, for example. Combine your if and else statements into a single if statement, checking if input is equal to 0 or 1. Or input equals 1. And use the string function to convert input into a string and return it. Okay, so return string input. Okay, because it's like a falsy value. I can get rid of that. Okay, should be good. Yep. Now your decimal binary function is complete. Feel free to test it out. If you're still confused, okay, create a new function called show animation. Function show animation. Leave the body function for D for now. You'll show the animation when users try to convert the decimal number 5 to binary. Okay, so you need to add a check for that within your check user input function. So if the value is 5, if the value attribute of number input, if number input dot value equals 5, then we have to do something. Remember to use parse int function to convert the string into a number. Okay, I have to use parse int here, parse int. Okay, leave the if statement empty. Okay. If the value of number input is equal to 5, call the show animation function and then return early. Return. Okay. Now your show animation function is set up, but if you look at your check user input function, you'll notice that it's calling parse int convert into a number several times. This is generally poor practice, so we should do that all at once. To fix this, create a new variable to store the converted number. Okay, so create a new variable. Let input int equals number input dot value. And it should be parse int as well, right? Parse int. We should parse it. Yep, okay. Then replace all these instances with parse int, okay. So I can just do Control D on all these. Yeah, so quite a bit. Although I shouldn't do it on the first one, right? I should just do these 4. So I can just do this here. Okay, and that should be input int. There we go. Perfect. Much shorter. Now that your show animation function is set up, let's do some testing. Add 3 console logs. Okay, console.log to log the text free, and then code camp to the console. Okay, free code camp. You should see the text in the console when you enter 5 in the number input. 5 console convert FreeCodeCamp. Okay. Before you start writing code for the animation, let's take a look at the function you'll use to add and remove elements from the DOM, set timeout. The set timeout function takes 2 arguments, a callback function and a number, representing the time in milliseconds to wait before executing the function. For example, we can wait 3 seconds before locking this, and that's how we would do it. Use the set timeout function to add a 1-second delay. Okay, so I just have to wrap this within set timeout. Okay, bring this up, and then a 1-second delay would be 1000 milliseconds. Then see what happens after you enter 5. Okay, so if I do 5 here, console, and I convert, it waits 1 second before doing code at the end. Okay. If you test your code, you'll see, yeah, code 1 second after, but free camp comes before, so it doesn't log in the right order. Because set timeout is asynchronous, meaning it doesn't stop the execution of the rest of our code. So yeah, free camp is logged immediately and code is logged after 1 second. One way to fix this is to use multiple set timeout functions. Use set timeout to log free to the console after half a second. Okay, perfect. Where's my stuff? There it is. Give me the set timeout. It should be free, and it should be 500 milliseconds, or half a second. While asynchronous or async code can be difficult to understand at first, it has many advantages. It allows you to write non-blocking code. Yeah, asynchronous stuff is pretty important to understand. You can start an async operation and other parts will still work. We'll learn more about async code in future projects, but set timeout is a good introduction. Add a 1500 millisecond delay for camp. Okay. Gimme, 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 gimme. Gimme this code. Paste. It should be camp and 1500. Now you're ready to start on the animation itself. Use an array of objects. Let animation data equal empty array. Next, we need to create an object to represent the first frame of our animation. Our object should have two properties or keys, input value and element delay. Input value will represent the value of the input each time your recursive function runs, and add L delay will be the delay between adding DOM elements to the page. Add an object to animation data. Okay, animation data.push or something. Wait. Oh, okay, I'm inside, so I have to just add an object. With an input value set to 5, and an add L delay set to 1000. Okay, so that would be 1000 milliseconds, I'm assuming. Recall the call stack is LIFO, last in, first out. This means that as functions are called, they are added to top or end of the stack, and as they are returned, they are removed from the top of the stack. So we need to treat our animation data array as a stack and add a new object to it. Treat our animation data array as a stack. Yep. Your new object should have the properties input value set to 2 and 1500. Okay, so let's just copy this down, hold shift down. It should be 2 and 1500. Yeah, okay. 2 and 1500. Another object to animation data array. Okay, bring this down. Should be 1 and 2000. 1 and 2000. Okay. Now you start building the animation itself. First, use the document.getElementByD document dot get. I should just copy this. Why am I typing it out? No need. And select the element with the ID of this animation container and assign it to a variable called animation container. Also, you can double click to just grab the word really quickly. Here we go. What am I doing? Should use const. Okay, not let. Next, clear out your show animation function by removing all the set timeouts. Okay. Now you start building the animation itself. First, set the inner text property result. Result.inner text equals call stack animation. Next, use for each method to loop through the animation data array. So we can do that on the animation data array itself. So dot for each, and it create. You can do a callback function like so, and this would be like the object as a parameter, and then the second parameter is the index, but we don't need the index for this. Leave it empty for now. Since you have the timing for each frame of animation stored in add L delay, you can use the value with set timeout. Let's set up within the body of for each method callback. Okay, we're in that. Add a set timeout function. Okay, so set timeout. Pass in an empty callback function as a first argument and object dot add L delay as a second argument. Perfect. Then use the compound assignment operator to set inner HTML of the animation container. Container.inner HTML plus equals to an empty complete literal string, which would be a backticks. Okay. Within the template literal, add a paragraph element. So like that, with an ID equal to $. We add something to it, to an empty string. Okay, does that work? I need the ending p tag. Is that fine? No. Okay, I just have to put an empty string here. Like that. There we go. Next, use string interpolation to, okay, now we have to use $. With that. My God. To the input value property. Okay. Okay. Use the string to set the ID attribute to the input value property. Object.input value, like that? What? That would be this. So 5, 2, and 1, I think is what they want. No. Input value of objects. Oh, I forgot the quotes around this. That should be good now. There we go. Add a class attribute. Set to animation frame. Class equals animation frame. Should be good. Finally, use string interpolation to set the text of the paragraph element to. Okay. Okay, I'm inside of the backticks. Set the text to that. Okay, so $, this, and just add this in there. Wait, what? No, just paste it. Current value is the input value property of the current object. Current value. So I have to remove this and do object.input value. Test your code by entering number 5. This should. Wait. I'm pretty sure this has to be inside of this for it to be JavaScript, and I should just get rid of this $. Part here. No, that's not right. You should use string interpolation to set the text of the paragraph element to decimal to binary. I'm running this function with object.input value in it and clicking the convert button. What the heck, man? 5, convert. It's not working. Why is this not working? I'm inside the backticks. Why is this not working? Okay, let me just put this in there then. I guess that's what they want. Okay. Let me just see here. 5, convert. Okay, so it's not showing yet. Oh, there's the call stack animation, I see. Now it's time to set up the next phase of the animation where you'll update and remove the paragraphs you append. Add the property message to the animation object. Add the property message to the animation object at the top of the stack. Okay, so this has to be message, MSG. Set it to an empty string. Set the value of the message property to this. Okay. Next, add the property show message delay with the value 5,000. Show MSG delay with the value of 5,000. And remove L delay remove L delay with value of 1000. Okay. What? Oh, 10,000, not 1000. For the object in the middle stack, add the property message with this value, right? MSG, paste that in. Also, the other properties show MSG delay set to 10,000 and remove L delay set to 15,000. Okay. For the last animation object, add the property of this message. We got some busy work here. Don't you just love busy work? It's great. It's fantastic. I love it. Oh my god, I love it. Show message property. Also, I forgot a comma here. So show message delay set to 15,000 and remove L delay set to 20,000. 20 seconds, damn. For the next phase of the animation, you'll update the paragraphs with the message text. Update the paragraphs. Okay, since you have the delays for each step of the animation already, you can add your code to the same for each loop, which I'm probably in right now. Yep, okay. Add another set timeout function. Set timeout. Pass an empty callback function, of course. And pass in the show message delay property of the as a second argument. Okay, so that would be object dot show message delay. There we go. You have, okay, so we're inside of our set timeout. You have set the ID attribute for your paragraph elements to the object input value property. Now use the get element by ID. Get element by ID to select the element with the attribute value, which would be object.input value. Okay. Wait, I have to do something. What is the element.get element by ID? Wait, what is it? You target the element where it matches the value of input value. Okay, this has to be not in quotes. What am I doing? I'm getting there. Oh, wait. Not get element. On what though? What document? God dang it. Document.get element by D. There we go. Perfect. Let's go. Step 104, we're almost there, guys, almost done. Now that you've targeted the correct element, you can update its text after the delay you specified earlier. Using the getElementById method, set the text content property equal to the message property of the current object. Set the text content of the targeted element. Okay, so we have to set this text content. So text content equal to object.msg, like so. There we go. Next, you'll remove the paragraph elements from the show animation element. Add a set timeout function. Okay, pass in an empty callback function as the first argument, and pass in remove L delay of the objects. Remove L delay. Okay. Use the get element by ID method to target the element with the ID attribute. Document get element by ID of the input value .id of the current object. Wait, won't that just be object.inputVal again? I think. Then use the remove method on the element to remove it. So dot remove. Okay, perfect. Now your animation is complete. When you enter 5 and do convert, then we get that, and then they get popped off. Turns 1 as the base case, then like 5 seconds later, then this thing returns 1, gives a value to stack below and pops it off, and then this returns that, then pops it off. And then we're done. Wow, what a great animation. Gosh, we're geniuses. What do we have to do now? Last thing we need to do is add the result of converting the number 5 into binary to the page. Yeah, what the heck? After the for each method, add another set timeout function. Set timeout and delay of 20 seconds. Okay. Finally, set the text content property. Text content of the result.text content equal to decimal to binary with 5 as the argument. And then we just finished it. Okay, so if I do 5 now, but it's going to wait 20 seconds, which is a long time. And I don't really want to watch it. We know it'll work. Here we go. Well, there we go. We completed our recursion by building a decimal to binary converter. So many challenges, very, very boring. Um, we learned a little bit, but it's still very confusing. But anyway, the next project we have is build a Roman numeral converter project. I'll see you in the next video, and peace out. Bye.